In this video, we're going to be looking at radical expressions and doing operations with radicals like adding and subtracting radical expressions and multiplying through the distributive property. In order for us to be able to add or subtract radicals, we need them to be what are called like radicals. Like radicals are two radicals that have the same radicand and index also. That's probably something else that's important. So have the same radicand and index. Remember, the radicand is the inside part of the radical. We call two radicals that have that like radicals. So some examples of like radicals would be these. 4 rad 3, negative 3 rad 3, square root of 3, 5 rad 3. And you can see that all of these have the same radicand, right? They all have the same radicand, and all of them are index of 2. Now, 2 rad 5 and 3 rad 7, they have the same index, but they don't have the same radicand. So 5 and 7 are not the same, so we would not be able to add these. So let's take a look at some examples of adding and subtracting radicals. So again, we make that note here. In order to add or subtract radicals, they must be like radicals. So it's very similar to if you were adding or subtracting expressions with variables, which is kind of why we're including it in this part of our unit. So if we thought of rad 2 as x, this would be 1x and this would be 3x. If we were adding this, we would just get 4x. You just add the coefficients. Similarly, in order to add radical expressions, they need to have like radicals. They need to be the same radicand, same index. And you would just, again, add the numbers that are in front. So if it's just 1 square root of 2 and 3 square root of 2, in order to add them, you just add what's in front. So remember that if it's not written, this really has like an implied 1 here. So 1 plus 3 is 4, and they keep the square root of 2. It's as simple as that. In this situation, again, implied 1, they both have the same radicand, rad 10 and rad 10, and you would subtract 1 minus 5. So we're subtracting a larger number from the smaller number, so we're going to get a negative value. So it's going to be negative 4 rad 10. Now, when you're simplifying these, since it's asking us to simplify, it's assuming that our radicals are in what's called simplest radical form. So what that means is we're going to have to break down the radical and take out any perfect squares if possible. Now, neither of these, square root of 2 or square root of 10, can be broken down any further. So in this case, we're going to be good to go. In this, again, we want to simplify these expressions. So at first glance, you might think, well, okay, we can't add these. They don't have the same radicand, so we're done. But actually, what we're going to have to do first is check and see, can these be simplified before adding or subtracting? So square root of 3, we can't really break that down any, right? Because its factors are 1 and 3. But what about 12? So if I break down 12, 12 is 4 times 3. 4 is going to be 2 and 2. So if you remember our rules, if we get a pair, we can take one of those out. So a 2 is going to come out of our radical and the 3 will stay in. So we're going to be left with 7 square root 3 minus 2 square root 3. So now you can see that these do have the same radicand. So now we just do subtraction like we did before. So 7 minus 2, that's 5. And then since they had the same radicand, we could subtract them. So we end up with this. What about this one? Can we add or subtract these two? At first glance, you might think no. But again, you have to think to yourself, can these be simplified before I try adding or subtracting? Square root of 2, again, it's 1 and 2, so nothing can happen there. But what about with the 8? So 8 would be 4 times 2. And 4 is 2 times 2. So again, we have a pair, which means we're going to be able to take one of these 2's out. The unpaired 2 is going to stay inside our radical. So we're going to have an unpaired 2 in our radical. This 2 comes out, but notice we already have this 3 out in front. So this 3 and this 2 that we're taking out of the radical are going to multiply. So 3 times 2 is 6. And then we have negative 2 rad 2 here that's being added to our 6 rad 2. So negative 2 plus 6, that's going to be 4. And we're going to be left with 4 square root 2. Okay, so let's try one more, or take a look at one more problem type. So in this last problem type, it's asking us to simplify this expression, and we are simplifying through multiplication. So remember, when there's parentheses here, that means multiply. So we're actually just going to use the distributive property. So we're going to take this square root of 3, and we're going to multiply it into both of these terms. Now, if you recall, when we talked about radicals earlier and simplifying radicals, in order to multiply two radicals, they had to have the same index. And then when you're multiplying radicals, you just end up multiplying what's on the outside of the radical and then what's on the inside of the radical. So in this case, we have a square root of 3. On the outside, there's that implied 1. And then we have this square root 6. And again, on the outside, there's that implied 1. So when we multiply, the 1 and the 1, those cancel. So we're just going to get 1. And then the 3 and the 6 will multiply to give us the square root of 18. So we have a square root of 18. We don't really need to write the 1. We have the square root of 18. And then we have the square root of 3 times the 7. Now, the 7 doesn't appear to have a radical, but we really could think of it as 7 times the square root of 1, because the square root of 1 is just 1. So if we were multiplying this with this, the 1 and the 7 would multiply to give us a 7. The 3 and the 1 would multiply to give us a 3. So we have this. Now, we're not quite done, or we have to actually verify if we're done first, because we have to look at whether these can break down and simplify. So 3 can't. 3 and 1, we know that nothing's going to happen there. 18 maybe. So let's look. So what is 18? 18 is 9 times 2. 9 is 3 times 3. Again, the index is 2, so we're looking for pairs. So we have a pair of 3s. So this pair of 3s can come out. The 2 will stay in. So we have 3 times the square root of 2 plus 7 times the square root of 3. And can we add these? Well, actually we can't, because they don't have the same radicand. In order for us to be able to add these two expressions, they would have to have the same radicand. So this is actually our simplified expression. Try this one on your own. See if you can do this on your own. So pause the video, try this problem, and then we'll come back together and talk about it in just a minute. Okay, so did you end up with this? 3 square root 5 plus 5 square root 3? Or at least did you get to this part here, 3 square root 5 plus the square root of 75? You might not have recognized this breakdown here. If you did, that's great. That's what we need to do. But remember, when you're multiplying, the radical, and when it multiplies a constant, essentially you just kind of put the two together. And then when you multiply your radical with your radical, you multiply the outside parts and the inside parts, and that's going to give us 75. So 75 is 25 times 3. 25 is 5 and 5. Since we have that pair of 5s, we can take a 5 out. The 3 that didn't get paired stays in, and then we have our 3 rad 5. Now, these cannot be added together because they don't have the same radicand.